Hello, everyone. Welcome to the Y Axis Pod. I am your host, Tristan Yver, and today I have an episode with Keone Hon, the co-founder and CEO of Monad. Welcome, Keone.
Hey, thanks for having me, Tristan.
Yeah, absolute pleasure, man. We've known each other for a while, so it's good to be able to dig into what you're working on these days. To get started, would you mind giving a brief introduction of yourself?
Sure thing. My name's Keone. Prior to starting Monad, I worked in the high frequency trading space for about 10 years. The last 8 of those were spent at jump trading. And high frequency trading is an interesting industry, involves building really performant systems as well as dealing with a ton of data and kind of getting familiar with just the scale of global financial systems. And the exchanges that we were trading on would generally send hundreds of millions of messages per day, even when filtering for the symbols that we were interested in. And we had to build systems that could cope with that scale of data as well as respond on the order of microseconds and decide whether to send orders. So that was a really good experience. After that, joined the crypto division of Jump Trading for a little bit, which Tristan is how you and I guess, first got connected and got to know each other. I was mostly working on Solana DeFi along with my coworker James, who I started working with in 2014 when we were just working on high frequency trading stuff together. We were both working on Solana DeFi. And then after about 7 or 8 months in Jump Crypto, just got so excited about the space of decentralized computation that we decided to leave and start Monad together, along with our third co-founder, Eunice, who has a product background. So I can tell you more about that, but just wanted to mention that that was kind of our origin story. And yeah, then I've been working on Monad for about a year and a half.
Yeah, I think that's an incredible origin story because also it's interesting because you kind of I don't know if saying coming up the stack is correct, but you went from perhaps working at microseconds to working at blockchain speeds. And I'm really curious, what was the thing that said in your mind, hey, I want to go build a blockchain? I think this is actually interesting, even though let's say it's slower than the stuff you were doing on the centralized side.
It's a combination of things. One is that blockchain technology itself is just really cool. It's really cool that with decentralized apps, you can build something, deploy it, and then have other people permissionlessly start building other apps on top of the app that you originally built and can call into the functions that you wrote atomically and have the functionality that you wrote that maybe originally was tended to be very user facing can actually just be subroutine inside of someone else's larger application. So the composability aspect was really exciting. Also, the idea of really just taking advantage of the properties that blockchains have that are really powerful, the instant settlement, the um, the self-custodial nature of assets, not having to trust centralized entities. And yeah, there were just a lot of things that were really exciting. It's really cool space. And it was also very exciting seeing people building applications that have the potential to replace existing incumbents and disintermediate these middlemen and just directly provide services that anyone can access. That mission was really exciting. And after working on this directly at Jump Crypto, James and I just couldn't not work on in crypto. And then at the same time, we also realized that our previous background, which was building these really high performance systems, was actually really relevant to solving a problem that in our eyes had not been fully solved yet, which was the problem of making the Ethereum Virtual Machine really performant. So I think overall it was just kind of a confluence of interests and excitement, and then also realization that our background was well situated to address problems that actually were quite pressing in the space.
Yeah, for context of the listeners, Keone's reputation at Jump was the beast, the guy who would get on things and get them done and figure it out. So it's very impressive that you actually decided to go from that environment where I feel like you were given hard problems and challenging things to work on, and then actually take a step even further and say, hey, I want to do even harder problems and do things that haven't been done before, rather than trying to like take ticks off the orders or whatever you were doing at that time at Jump. One thing that you said that I thought was really interesting is making EVM performant. But before we go into that, I'd love to hear how you describe Monad, how you talk about it to the world, and like what's the, let's say, the pitch when you talk about it.
Sure thing. Monad is bringing pipelining to the Ethereum Virtual Machine. Monad is a new ultra high performance layer one that introduces a bunch of new architectural improvements, which are really summarized as pipelining. It's a new practice that we're hoping to bring to the Ethereum space that ultimately leverages resources that the different nodes in the system have more efficiently by creating stages of work that can process work intelligently in parallel. And in particular, Monad introduces pipelining in four major areas that are all different areas that represent different bottlenecks that we see in the transaction processing right now. And I'll mention those really briefly, but I don't know, Tristan, if you want to hear more about any one of them in particular, I can dive in a little bit more. But just to mention them briefly, the four areas of pipelining are state access pipelining, so making the state a lot more accessible in terms of reading and writing from the disk. The second area where we introduce pipelining is in the parallel execution of individual transactions within the block. The third area is pipelining between consensus and execution, which are kind of the two major areas of a blockchain, introducing that work in stages and then running consensus and execution in parallel in a slightly delayed fashion for the execution side. And then finally, pipelining within the consensus mechanism itself. There's kind of an element of parallel communication where multiple stages of the consensus protocol are communicated at the same time. And so when you put all those things together, that enables the Monad system to process transactions that are, transactions that are interacting with Ethereum smart contracts. Monad is fully bytecode EVM compatible. And that means that any application developer who built their application for Ethereum can redeploy on Monad without any changes. And it allows Monad to basically process at 10,000 transactions per second of throughput, ultimately helping to scale the Ethereum virtual machine substantially. Sorry. And by the way, it made me realize actually that when I described Monad at the very beginning, I missed the most important thing, which is like high performance, fully bytecode EVM compatible layer one. So I don't know what it's like every time I tell the story, I tell it a little bit differently and somehow miss that.
No, that's good. We'll make sure that people realize that things can be deployed directly. But getting back into this, I'm curious around this idea of pipelining. Did it come from things that you had worked on initially in TradFi and trading? Where did you get the inspiration for this?
Pipelining is actually a term from traditional computer science and really describes in traditional computers how the CPU can execute instructions much more efficiently. Pipelining in a CPU is the process of executing stages of work through multiple phases that ultimately allow the CPU to execute multiple machine instructions in parallel. Every CPU out there basically has pipelining under the hood. And for us on our team, we realized that it was pretty crazy that Ethereum and other Ethereum compatible blockchains basically are all single threaded. They all just execute transactions one after the other, start the second transaction after the first one finishes processing. So that was one, in Monad, that's one specific area where we've made some architectural improvements that allow the system to process transactions a lot more efficiently. But then while we were working on that, we realized that, some of the other really big bottlenecks are related to accessing state, reading all of the state variables of specific smart contracts. So then we started to work on how to make that more efficient. And then that ended up being also basically a pipelining situation where we've introduced asynchronous reads and writes to do batched reads and writes from disk. And then as we're working on that, then we realized that there's another big bottleneck, which is that when nodes are coming to consensus, execution is generally a prerequisite to that, meaning that within the block time, very little portion of that block time can actually be allocated to execution because almost all of it is spent on consensus, on the nodes talking to each other all around the world. So after we realized that, then we made changes to basically move the execution out. And in general, all of these efforts come from direct observation of where the bottlenecks are in Ethereum execution and alleviating those by making changes.
And this is a very ignorant question, but if you have, let's say, the Aave code that's deployed on Ethereum, and then you redeploy that on Monad, how does that become so much more performant? It's that because there's a separation of the layers there? What's the working process?
Yeah, that's a good question. So, like you said, the Aave code or any bytecode that's been deployed to Ethereum could just be redeployed on Monad without any changes. Then, when people are interacting with that smart contract, they just submit transactions that call specific functions. And in order for that transaction to be executed, the virtual machine has to pull the bytecode for that Aave contract from disk, as well as the state that's associated with it from disk, and then step through individual opcodes in order to execute whatever code is inside of the function that's being called. And in Monad, exactly the same thing happens, except there's at each layer, like in the execution layer, we actually have multiple executors going on in parallel that are doing multiple transactions worth of work in parallel, producing pending results, which can then later get combined into the original sequence of transactions and produce ultimately the same result. And then I guess similarly at other stages of the overall process, such as in the consensus part, there's also work that's being done in parallel to do the execution.
So rather than if I went and deposited into Aave on Ethereum, and then you went and deposited into Aave on Ethereum, and that being ordered sequentially and waiting for my transaction to go through before yours goes through, these are happening in parallel in the Monad. Essentially, would it be right to describe it as a Monad VM?
Right. That's correct. Monad has a VM that behaves similarly to Ethereum in terms of bytecode support, but differently from Ethereum in the sense that there are multiple Monad mini VMs that are going on in parallel, that are doing work in parallel.
One thing I'm really curious about, which I think is a big question for a lot of builders, we recently saw Rune come out and say, "Hey, we're going to actually build our new chain with this other VM." What was the decision process behind staying in the world of EVM and taking on such a hard problem, which is sort of scaling that solution, something that even with the rollups and other things that we've seen haven't gotten that far as of yet?
Yeah, we think that the Ethereum Virtual Machine is just really important to the crypto space. Realistically, it's where almost all of the TVL is right now. Most applications right now are built for the EVM. And then also there's a lot of, people always think about developers, but they don't think as much about researchers. Like almost all of the applied cryptography research is all being done in the context of the EVM as well. We basically think of EVM as being kind of like the JavaScript of the early 2000s, where it was the dominant standard, but then it was just really slow. And over time, people came in and made improvements to the JavaScript runtime For example, Chrome, Firefox, all of these browsers, they have much better JavaScript runtimes now. And as a result, that standard has endured, even though at the time it seemed like it was very not performant compared to some other alternatives. We see that we feel that way about the EVM right now, where it's the dominant standard, but it's just really inefficient right now. And hopefully, by making it more efficient, we can allow crypto to scale to many more users and all these decentralized apps to scale to many more users.
Right. It's a very hard problem, but it's potentially the most valuable problem to solve at the moment with the state of crypto.
Yeah, I think at least for our team and given our backgrounds, it's the right problem for us to solve. I think that there are other really important problems that other people are solving where they're the expert in that thing. Like I feel that um, user experience is really, you know, leaves a lot to be desired in crypto. There's a lot of you know, non-crypto natives who get really confused when they see a traditional wallet or so I think there are other people that are doing other important things. I just realized I was giving you a shout out with Backpack, but um there's we all have to work together to address whatever adoption problems exist in crypto. For our team, because we're high performance experts, um of course it makes sense to address this problem.
And is it correct to describe Monad as a monolithic blockchain that can essentially do all of the processing without needing necessarily like a settlement layer? Or how would you compare Monad to say Arbitrum or some of these other solutions that are popping up on the EVM side?
Mm. Yeah, it's an interesting question because the monolithic versus modular debate has become a really popular one over the past 2 years or so. I feel like it's actually because it's the kind of, I don't know, almost like a false dichotomy or something like where the fact that I'll say two things. First thing is like, the best Twitter polls are the ones where you give someone two choices and then, it's exactly like 50-50 between the two choices.
Hmm.
And I feel like it's kind of like that here where like there are really merits to both adjectives. Um, monolithic is good because it means like it's a full complete system. Everything works and it's all optimized together. But the modular also sounds good because it's like, it means you're cooperative. It means that you're working with other people and other people like, in crypto we value collaboration so much. So like embracing that culture of collaboration very directly by saying we're only going to build partial solution that has to integrate with other solutions in order to fully deliver an experience. That sounds kind of good as well. So that's the first comment I have. I think the second one thing I want to say is that Monad actually is a modular system as well. Like the Monad blockchain has several major components and they are separate modules that work together and there's junctures between them, but like any sane person, like we design it with those subcomponents and with those junctures. The obvious some of the obvious ones are like the separation that Monad has between consensus and execution. That's actually a lot more modular than other blockchains because we literally separate the consensus and the execution into separate stages of work. We do the consensus first. The nodes come to agreement about the official ordering of transactions without executing. And then after that happens, then the process forks into two separate things where one starts producing, starts doing consensus for the next block. And then the other stream of work is going and executing all the transactions that we just agreed upon. So yeah, I think that Monad is ultimately quite a modular blockchain as it is, but it's also intended to be a complete solution in the sense that it's fully able to process transactions, maintain shared global state, thus supporting a lot of decentralized applications and a lot of users without an external dependency in terms of the overall consensus and execution part.
Yeah, I think that's a very nuanced answer. Perhaps one of the more nuanced that I've heard so far in this debate. As you said, it is kind of the hot topic or the thing people like to discuss right now. And it's true, it does put people in bands when sometimes there's a lot of overlap and those bands don't necessarily exist so clearly. One thing I've seen is that you guys seem to have a lot of core Ethereum people support, or people that are very excited, who have been in the space for a long time on the things that you're building. Has that been your impression overall? Are you being received well by the EVM community, or has there been some pushback?
Yeah, I think honestly, everyone has been really supportive. And when we talk to people in person about the effort and why we're working on what we're working on, people are generally like, "Oh, that's awesome! Like, we really need someone to be working on that." And sorry, just to back up a little bit, what I would say is unique about Monad is that we're rebuilding the EVM execution stack from the ground up and introducing pipelining, introducing these parallel stages of work, um, introducing custom state backend, is introducing these changes um, so that we can make the Ethereum virtual machine scale. And I think the fact that, there's a lot of different teams that are working on different things, but to my knowledge, no one is working on making EVM execution more performant. So the fact that we're doing something very unique is seems to be generally well received. I'd also add that, at the end of the day, a lot of the innovations within Monad are quite orthogonal to other things that other teams are working on. So, for example, roll-up teams, they spend a lot of time building really sophisticated proving systems, either through the fraud-proof system and making sure that it's possible for that to be decentralized. For example, Arbitrum released the bold, new fraud-proof mechanism, which they say will allow them to eliminate the whitelisting aspect of people submitting fraud proofs. Like, that's really great. They put a lot of work into that. Or zero knowledge proofs. Like, clearly they're really talented teams that are spending a lot of time building these really complicated proving systems. But all of that is to say that that's a completely orthogonal effort to the problem of executing transactions within a node really efficiently. And so maybe someday, in the future, it could be a couple of years from now, but there could be rollups that are built using Monad's execution stack so that all of the work that the proving teams did can combine with all the work that that our team has been doing on the execution side, and just build like a super roll-up node that can process a lot more transactions than roll-up nodes can today, and are more secure than the current roll-up nodes are today because of the advances that the roll-up teams are making. So overall, it's just a completely orthogonal effort, and I think that's the reason why folks in the Ethereum community have been super supportive.
I think you touched on something very profound to our space there when you talked about others taking the work you are doing and then being able to build on top of that, which leads me to a bit of a personal question, which is, when you were working in the trading world, everything that you build is ultra secret. There's no way you can talk about any of it with anyone outside of even your specific team that you're working on that with. But now you've pivoted completely to something that everything that you build is in the public domain and can be used, forked, taken, done whatever by external parties. Was that part of the driving factor? Is that something that you wanted for your work to live out in the open, or is that just coincidental with the problems you want to solve?
Yeah, I think that's totally accurate. When James and I were part of this trading team at Jump, we were writing code that 10 people had access to, and doing all these really intricate optimizations, and coming up with some really cool new architecture that, I mean, I wouldn't say it wasn't impactful, because it definitely um, made an impact to these trading strategies that go, yeah, that would just would generate money. Like, it's obviously cool to see like the market feedback very quickly. But yeah, that wasn't open source by any means and had a limited societal impact. And then also there, we would only be collaborating within this very small team of like 10 people, as opposed to in the crypto space where there are many open source contributors, and there are people who are just, making suggestions and opening pull requests and forking and making changes and building on top of existing stuff. So definitely very appealing to be part of the open source space and the culture that the crypto developer community has.
Yeah, good to have you on this side of the fence. I think we should go full circle back to where we started the conversation, which was around this topic of pipelining. I'd actually love for you
Mm.
to dive in to these four different pipelines that you guys are building slash optimizing. I don't know the best way to describe it. And would just love to hear your brain dump as you talk through the four different systems. You did talk a little bit about how you thought it was just going to be transaction processing at the beginning. And as you started solving that, you realized that there were parallelizations and optimizations to be made in other things that would also allow for that to be better. But I would just love to hear the brain dump from you on this.
I think it would maybe be best to start by just describing the life cycle of an Ethereum transaction on Ethereum. And then I'll kind of get into, some of the changes that, the comparison between that and Monad. So for Ethereum, people submit transactions. The way those transactions are actually made is by user going to a website, generally speaking, user go to a website, clicking a button, and then the website prepares a transaction, which then gets presented to the user who then signs it using their wallet. Wallet is holding the private keys. After the user signs it, then it becomes a signed message. And then the signed message gets sent to one node in the system, specifically to the RPC server of that one node. And then that transaction then goes into what we refer to as the mempool, meaning that it's in a pending state. It gets messaged to all of the other nodes in the system, generally via gossip. So a peer-to-peer protocol that it's kind of like a whisper network for all these pending transactions. The transaction then lives in the mempool for all nodes. So hopefully it's gotten propagated to most or all of the nodes, within a couple of seconds. And then within Ethereum, there's a rotating leader mechanism where one of the nodes that's participating in consensus. So sorry, just to take a step back here. The Ethereum network is just composed of all these nodes that are all perfect replicas of each other, meaning that they all have all of the same state. They all have all of the exact same smart contracts installed on them, and they have all of those smart contracts all have all the same state as well. These nodes are all kept in agreement with each other via a consensus mechanism, which is sort of a protocol, like an elaborate series of handshakes by which all of the nodes communicate about a pending block, which has a bunch of transactions inside of it. So they all agree about what that pending block is going to be. And then once they all agree, then they all execute the list of transactions that are in that block and update their state accordingly. So all of these nodes are staying in sync with each other because they're all doing all of the same work in parallel. And the way that they agree on the work that they're all going to do is through the consensus mechanism. The consensus mechanism is a pretty elaborate thing as well, but it's a protocol that allows the nodes to come to agreement while also tolerating the possibility that certain number of the nodes might actually be malicious and might be sending confusing messages like voting no when they should vote yes, or voting yes when they should vote no, or even, as the leader sending a bad block. The consensus mechanism is designed to be robust to a certain fraction, generally 1/3 of the nodes in the network being malicious. As long as 2/3 of the nodes in the network are not malicious, then the network is able to continue producing new blocks and coming to agreement and progressing the sort of system forward. Okay, so all this still didn't really answer your question. And all this is just to give some background on what Ethereum does. And I guess the purpose of all of this is so that we can have shared global state across all these nodes. so that they all have perfect agreement. Because if they have perfect agreement, then any one of those nodes' state is actually the state of Ethereum, and that means that we can have applications that just live in this kind of nebulous space of like existing on all these nodes. And it means that we can have decentralized apps that people can go use in place of a centralized authority. So that you could then have a decentralized app like a virtual bank that emulates what a real bank does. A real bank is a place where you can deposit money. The bank gives you interest on those deposits, and then the bank goes and loans the money out to someone else, and the someone else pays probably a higher rate. The bank makes the spread between the high rate and the low rate. The borrower gets a loan which they can use for some productive economic purpose, and you, the depositor, get interest on your deposits. So everybody wins in that scenario. A bank is just a business, but a virtual bank is, aka a lending protocol like Aave, is actually also a basically a business, and all this can just be maintained through a smart contract, and this shared global state kind of enables that. So sorry, did I miss anything there? Because I
No,
think
I
I
think
gave
that
it
was
kind of
perfect. I think that was a really beautiful recap of the Ethereum network and the different steps throughout that network.
right. Okay, so with Ethereum, um, Ethereum has blocks every 12 seconds. Ethereum is a proof of stake mechanism, has a proof of stake consensus mechanism. Um, Actually, that's not really quite precise. Ethereum has a proof of stake Sybil resistance mechanism for how the nodes are going to choose leaders, as well as how nodes are allowed to vote. Ethereum has this consensus mechanism that produces blocks every 12 seconds. And Ethereum has a gas limit of about 1 million gas per second, where gas is a measure of complexity of transactions. And that roughly translates to about 10 transactions per second for a typical complexity transaction. Okay, now we kind of introduce Monad. Monad is a new system that is similar to Ethereum in the sense that blocks are linearly ordered and transactions within the block are also linearly ordered. Um, Monad produces blocks every second, and Monad has single slot finality, meaning that finality happens within a second as well. So compared to Ethereum, that's already blocks are 12x more frequent, and Ethereum has finality of 12 to 18 minutes. So Monad's finality is substantially faster than Ethereum's finality. Now, to talk a little bit more about some of the other comparisons to Ethereum versus Monad. Monad is fully EVM compatible, and it's fully bytecode compatible, meaning that literally the same contract that exists on Ethereum could be deployed on Monad without any changes. The transaction format is the same. The address space is the same. So that means that MetaMask or Backpack or any other wallet could seamlessly be used. That any wallet that's compatible with Ethereum is compatible with Monad as well. The way that Monad is able to achieve these speed ups is through a couple of different changes. The first change that I kind of want to mention is the consensus mechanism. So the consensus mechanism is a parallelized version of hot stuff. And in particular, it's pipelined hot stuff. So in hot stuff, there's a stage where the leader sends out messages to all of the other nodes, and then all the other nodes send acknowledgments back. And then there's another stage where the leader takes all those acknowledgments and packages them into what's called a quorum certificate, and then sends the quorum certificate back out to all the nodes. And then at that point, the other nodes talk to each other and vote, and then the votes get, sent back to the leader. So those are kind of separate stages, but we pipeline those stages so we can piggyback the broadcast of the quorum certificate we can piggyback that on top of the new block proposal for the following block. And so that allows the consensus mechanism to be a lot more efficient than traditional hot stuff. There's a lot of other details there, but just in general, the consensus mechanism has a lot of really great properties that allow it to be more efficient and also have this single slot finality property. And the pipelining that exists in Monad's consensus mechanism allow us to be really efficient with these proposals. I guess the second thing that I wanted to mention is in Monad, consensus and execution are separated from each other, which is different from how most other blockchains function, where execution is a prerequisite to consensus. And the reason why execution is a prerequisite to consensus in most blockchains is because the block proposal contains a list of transactions as well as the state root that results from after those transactions are executed. Whereas in Monad, the execution is moved out of that process. It's basically moved out of the hot path of consensus, and the nodes come to agreement about the official ordering of transactions without executing at that time. And then after the fact, as soon as consensus is completed and the nodes are in agreement about that official block, then each of the nodes goes and executes. This change sort of has a couple of downstream changes, but we do the hard work of making sure that the overall blockchain to the outside has exactly the same interface. Like the RPC interface is the same. Transaction to anyone from the outside, it kind of looks the same, but then under the hood, there's this separation of consensus and execution that really allows us to use a much larger execution budget. The reason why this change has a big effect is because now the full block time can be used for execution, as opposed to in an interleaved traditional system where only a small fraction of the block time could be allocated to execution, because most of that time is actually allocated toward consensus. And then just to complete the thought, the reason why in most systems, consensus takes up most of the block time is because nodes are potentially on opposite sides of the world. It takes a long time for messages to travel at the speed of light around the world, like literally hundreds of milliseconds. So if that were the limitation, that would actually really limit the execution budget substantially. Now, just to talk a little bit more about the sort of downstream effects of separating consensus from execution, I want to point out that finality is still achieved immediately at the point of finality on the consensus layer. So once a block is finalized, the official ordering of transactions is now enshrined into the history of the blockchain. And so the result is actually completely deterministic. All of the nodes have now agreed upon this official list of transactions to execute. Now they all execute those transactions. And because the nodes all had the same state prior to that, and then they all do the same list of work, so they all should end up with the same result. So finality has actually happens as soon as the nodes reach agreement about that official block.
Are there any cases in which that list of transactions, the ordering has been enshrined, it's basically final, but the execution doesn't occur for some reason with one of those transactions? Is there any type of spoofing that would be possible there, or is that not possible?
That's not possible. So, but just to unpack that a little bit, in Ethereum, when there's a block, there's a whole bunch of transactions in it. It's legal in Ethereum for transactions to revert. Like if, for example, if a transaction doesn't have enough gas to pay for all of the computation that is being done in it, then, when it hits the gas limit, then the execution will revert. but that transaction is still valid. It's just the, like the execution inside of it. The only consequence that it has is that it decrements the amount of ether in the account,
Mhm.
which is still like a legal, state transition for some of the ether to get spent in the account. Um, but yeah, I mean, I just wanted to point out that there's a difference between transaction validity and the execution validity. Transaction validity is always there and it's always deterministic. But then, yeah, just more generally, once the official ordering of transactions is determined, if there's several hundred nodes and they all start from the same state, and then they all go to execute that same ordering of transactions, they are all going to result in the same state. Um, but also just to defend against, I don't know, like cosmic rays that, mess up one of the machines, cause it to have a bit flip somewhere. We also do have a delayed Merkle root that's included in the consensus messages. So, um, the block proposal does also include a Merkle root that allows the nodes to kind of check their work and make sure that they all got to the same result. But it's just not a Merkle root for the state tree immediately after this set of transactions. It's like from a couple of blocks ago.
That's really smart. Yeah, the only reason I was asking because I envisioned what if somebody put transactions in saying I'm going to buy $100 million of X coin in this sort of when the execution occurs here, and that drives MEV market participants to do stuff, and then that actually doesn't execute on the back end. But that seems to be impossible. That was the thought that came to mind when I was asking that question. So like essentially
Right.
spoofing the blockchain.
Yeah. So in that case, it is true that like the person submitting that transaction to go make a big buy, like their transaction might not succeed, but it's not going to succeed similarly on all of the nodes because
Got it.
if there is some reordering of transactions relative to like submission time to the mempool, then the official ordering will have like some MEV bots transaction ahead of that big buy. So they'll all the nodes are going to get to the same result of either that buy succeeding or that buy failing. But
Oh
it's going
my
to be
God.
consistent across all the
MEV is
nodes.
gonna be insane on Mana. Just realized it's gonna be it's a different game, right? Because you just bring kind of the times down so much. Is that right? Or is there actually aspects that make it hard to do MEV here?
That's a really good question. With Monad, on day one, the Monad system will use a priority gas auction.
Hmm.
So that just means that, people just submit, they bid for priority, and then the transactions are expected to be ordered in the priority that people submitted. But the transaction ordering is kind of an orthogonal question from everything else. So everything I've described to you is just like, the leader proposes an ordering, and then everyone, votes on whether it's a valid block or not, and then they, finalize it and they execute. But I didn't tell you how the leader should choose the ordering. So the leader could, um, in the future, if there's like a flash bots or skip protocol or Jito, like the equivalent of one of those, that allows people to submit different ordering preferences, then I think that would work perfectly fine with Monad, and just, allow different kinds of orderings to get chosen. But I think the other thing I wanted to mention is that I know, a lot of people are really worried about MEV, and I understand the worry. Um, I actually think of MEV as really fundamentally coming from user loss. Like fundamentally, um, when someone makes a trade on an AMM, and the AMM has a liquidity spread all the way across the, X times Y equals K curve. So there's like not that much liquidity that's like, very close to fair value. So they end up having to set a pretty high slippage parameter and effectively reach pretty deep into the book, so to speak. Like if they maybe have to pay like 2% slippage or something like that, then it's, that action actually is a lot of user loss, because the user is ultimately like losing 2% of the value that they transacted, just coming from the fact that they they're interacting with a book that effectively doesn't have very much liquidity, that's able to take the other side of their trade. So, then that creates an opportunity for some other person to go revert the price. Like effectively, when that person makes that big trade that has 2% slippage, it moves the price 2%. Then that's an opportunity for someone else to come in and move the price back, revert it most or almost all of the way, and earn that 2% coming back. So, the user effectively lost 2% of their value, and then the other person has the opportunity to go get that 2% back, and claim it for themselves. And we refer to that second action as MEV. But, I want to frame it in terms of user loss because there's sort of an underlying fundamental problem here, which is that liquidity on decentralized exchanges is really bad, which then caused the slippage, which then caused the back running opportunity, which then resulted in some MEV bot, or a combination of the MEV bot and then the proposer in the case of flash bots, where the proposer ends up actually giving most of the value back to, sorry, the searcher gives most of the value back to the proposer in the form of a tip. All of this situation actually just arises from thin liquidity in the DEX. And so I want to highlight that because I think it is important to think about where did these problems come from? Like, what's the underlying root and how do we solve that? Because if it's a liquidity problem, then we have to ask, well, how do we solve this liquidity problem?
Yeah, amen to that. I think that's a good framing of it. But I totally sidetracked you. We were Tar, you were explaining to me how you had split execution from consensus,
Right.
and
Right.
I can bring us
Actually,
back there.
before we go back there,
Okay.
wanted to explain one other thing. I was just pausing for some random, I don't know why reason. Yeah, so there's basically a liquidity problem, but the liquidity problem actually is driven by expensive costs of updates on Ethereum. So, the reason why it's really hard for there to be good liquidity on Ethereum, on Ethereum dexes, is because good liquidity requires liquidity providers to update their quotes frequently to stay close to where the fair value is. If Bitcoin is oscillating between $26,000 and $26,500, 26,600, whatever, all these different price changes, the market maker should be adjusting their quotes all the time to stay close to fair value. And if they had to send a separate transaction that costs $10 each time, $10 in gas fees, which is what it would cost on Ethereum, then it's just going to be very uneconomical to make markets like this. So that's really why we have the rise of AMMs. These are more math formula driven environment pools of liquidity for offering a swapping environment, and that results in these formulas result in the liquidity just being spread over a wide range of prices. So the solution is really to enable an environment where a fully on-chain limit order book can exist and liquidity providers could update their quotes very cheaply, similar to Serum on Solana, but in the EVM space. And then that would then solve the liquidity problem, which would then reduce the amount of slippage that users are experiencing, thus resulting in less user loss, thus resulting in less MEV extraction opportunity.
Yeah, amen to that. Let's bring more liquidity on chain. But yeah, I really do want you to finish kind of the whole explanation that we were beginning earlier, which was this comparison to how you had initially laid out the Ethereum blockchain and now talking about how the things occurred differently on your end. And if I recall correctly, we had gotten as far as the explanation of the splitting of consensus or block formation, block ordering, and execution of those ordered transactions.
Yeah, so I think I described the sort of two of the sort of four major areas of architectural change within Monad. Next, I want to talk about pipelining of transactions and the idea of executing transactions in parallel while still supporting the Ethereum Virtual Machine. The way that I typically describe the parallel execution within Monad to people is, Monad basically supports the existence of many individual virtual machines that exist in parallel. Each virtual machine takes a transaction and steps through the bytecode, does the same sort of literally like the exact same logic that the Ethereum virtual machine does, and produces a result. A result is a list of inputs and a list of outputs. The inputs are the uh, accounts and storage slots and values that were read in, and then the outputs are the accounts, storage slots, and values that got changed. Executors produce results, and in Monad, we have a list of transactions in the block that we need to execute, and we always get to the same end result as if we had executed those transactions one after the other. So, but we try to do that in a more intelligent way, like in a parallel fashion, so that instead of just executing the transactions naively one by one, we produce intermediate results that can then be committed back in the same original order that the transactions were defined in. So just to kind of recap again, there's a bunch of executors that produce results, and the results are committed in the original order that the transactions were originally defined in. And because these results were produced in parallel, sometimes it's the case that, for example, transaction 4 and transaction 5 might have been executed in parallel. So results 4 and result 5, those are produced in parallel. And it might turn out that result 4's outputs have now changed some of the inputs to transaction 5, to result 5. So we commit these results in the original order. So we commit result 1, 2, 3, 4. And then when we get to result 5, we notice that the inputs actually changed. So that's the point at which we reschedule transaction 5 to be rerun. And this process of producing interim results, but then committing them back in the original order is what we refer to as optimistic parallel execution. So we're basically optimistically hoping that all these transactions don't collide, and then writing down the inputs and outputs, keeping track of whether they actually did collide. And in the event of a conflict, then we execute the later of the two transactions again. But overall, this kind of process is still very safe because every transaction can only get re-executed a maximum of one time. And also all the results are still committed in the original order. So they produce the same result as if they had just been executed one after the other.
With this parallelization or sort of optimistic, is it optimistic execution or optimistic ordering of transactions? What's the proper?
Optimistic parallel execution.
Okay, optimistic parallel execution. What other things did you guys realize once you got this far that you needed to optimize for and started optimizing for?
In optimistic parallel execution, like I said, the situation where there's a conflict and we have to re-execute, people like hear about that and they're like, oh no, that the re-execution is going to be really inefficient. Like, what if there's a lot of re-execution? But the reality of it is that most of the work is actually not compute bound, it's really IO bound. So the re-execution is usually quite cheap because we already have generally all of the inputs in cache, and re-execution is just a matter of stepping through those opcodes. But the opcodes are very efficiently implemented in C++. And oh my gosh, I forgot to mention the other thing. So Monad is fully built in C++ and Rust. So it's a really that's just another sort of improvement that exists over like the existing Ethereum clients, generally speaking, is that there's just been a lot of effort that's gone into optimizing all of the logic and optimizing the VM and optimizing the um, the communication, optimizing the processing of all these transactions. But anyway, the other thing that this really comes to is at the end of the day, a big part of the cost of execution is the cost of the state reads and the state writes. Um, with smart contracts, the reason that they're useful is because um, the contract has state associated with it. When you interact with Aave, a virtual bank, it's useful because you're depositing funds into it. That means that the smart contract is writing into its state somewhere that your address deposited funds, it owes you something. And then also when you're earning interest, like that's because the smart contract is incrementing your balance internally. So the state is obviously like the really useful thing. We also just talk about blockchains as being enablers of shared global state. So clearly the state is the thing that's useful. The state is the thing that's expensive because when you want to submit a transaction that calls a function, executing that function requires going and pulling state from disk and then doing whatever computation needs to be done and then committing the results back to disk. Those reads and writes are really the expensive thing. So that kind of brings us to the fourth and final area of pipelining within Monad, which is Monad team has built a custom state backend that stores data in a Merkle tree really efficiently and batches reads and writes to and from disk using asynchronous I/O to very efficiently do all of this disk access. So all of the disk access is very carefully marshaled through this custom state backend that our team has built. And I guess if you compare that to Ethereum or to other blockchains, most other blockchains use a high level key value store. For example, Ethereum uses LevelDB, Solana uses RocksDB. Different blockchains use the software to just store all of the state in kind of like a giant dictionary that is then used to store all this Merkle data. And so because these aren't, these are just generic key value stores, they're not optimized for the problem of storing data in Merkle tree. They're not optimized for the kind of access patterns that smart contracts have. This is just an area where our team has put a lot of time into addressing what we could definitely clearly observe as a significant bottleneck for Ethereum virtual machine execution. And with this custom state backend, we're able to process a lot more transactions.
Okay, amazing. Thank you for that breakdown. So we have the four main optimizations that sort of fed into each other as you started in one place and realized that you needed to go further and further with different pieces of this. Now I want to ask you, where does everything stand? So where are you guys in the process of building this blockchain?
We are in active R&D. We have built most of the components. We're very excited about the results and just excited about what's to come. We're targeting a mainnet launch of mid 2024, but there's still improvements that we think we can make to this initial version that ultimately will address where we see the existing bottlenecks still. We think will be really impactful to scaling the space.
And one of the really hard things about L1s is that you don't just have to think about the technology. There's ecosystem, there's tokenomics, there's all of these different pieces. Are you taking it step by step and sort of taking them as they come, or are you having to wrap your head around everything all at once?
You're right. Yeah, you're right that it's definitely challenging because um, there's a lot that goes into helping to support the growth of L1 ecosystem. I would say that the team has clear focus, and you have to be really focused. Like as a startup, as a an early stage effort, have to be really focused and really disciplined. And our team is really focused on launching our test net and um, also being really cautious about um, any and all corner cases because there aren't do-overs. Like we uh like we absolutely above all cannot be hacked. Absolutely above all, like need to ensure the liveness and safety of the protocol. So yeah, it's just a lot of effort that's going into sort of the very thorough testing um of the system and defense against corner cases, defense against DDoS attacks, defense against what happens like if there's someone who spams the network with 100 million messages in the span of seconds, things like that, in order to make sure that the network is super resilient. Because ultimately, we're building technology that has a potential to serve as the financial, the rails for all finance. So, it just needs to be really, really robust.
Are there ways people can already get involved? Are there calls to action you guys have, or are you guys waiting a little bit on that?
Um, I think the calls to action are, uh, yeah, I think the calls to action are in the sense that we're, we're hoping to collaborate with ambitious builders of applications, and by being fully EVM compatible, folks can start uh, building applications already in the EVM space and testing against hard hat or test against Foundry, and know that um, the Monad infrastructure will be a drop-in replacement for like that kind of environment. I think the team is still growing as well. So check out our open job listings, and please reach out if there's something that where you feel like you'd be a really good fit. Um, and then I think that there's also a lot of other orthogonal components that we're not the expert in, such as in user, like the overall like on ramps to crypto, user experience from a wallet perspective, um, trying to, yeah, I think there's just a lot of other verticals that we're not like the expert in by any means, and hoping to integrate. So I think that there's a lot to be done in all different areas.
Absolutely. I know that before this, you were very hands-on coding and you would do a lot of it yourself, essentially. Now, as the CEO of a pretty rapidly growing company, do you find time to code still? How do you find your time being divided?
Right. I definitely code a lot less than I used to. I think most of my coding nowadays is more like just one-off tasks, like scripting something, or writing Python code to automate something that would have that otherwise would be quite annoying. Um, but yeah, I mean, our team has really talented engineers who are much better at building um, really high performance systems, or really robust distributed systems than me. So it's actually quite fortunate that I'm not the one that's doing the most of the coding, or really all any of the coding on the blockchain at this point.
Amazing. Yeah, it seems to be the common transition there. My last question for you, in this last year and a half of your journey, is there any sort of fundamental lesson that has stood out above everything else, or thing that, really has stood out to you that you've learned from being the founder of a startup?
Yeah, I think speed is really important. I think that um, in the past life, I was very much a perfectionist in retrospect, and it's nice to have high standards, but also like you can't sit and spell check your email too many times. You have to just send it. Um, Send the damn email. Like, don't. I think the space is very honestly very forgiving in terms of like, or very welcoming in terms of people being very friendly and open to collaborating. And so just taking initiative and reaching out, trying to see if there's opportunities to collaborate or work together. That's just like an instinct that some people have, and that is a superpower, and is something that I think I wish in retrospect I'd been just, like I said, faster, more willing to like reach out and put myself out there a little bit. Because yeah, I think it's also like I could project, like even back then, like if you'd asked me like what I thought the lessons would be, I probably could have predicted this, or I think I did predict this, but it's just like in practice, like sort of implementing that, and as opposed to just being like a theoretical thing.
Amazing. And well, thank you so much for coming on this podcast. Team Hawaii and crypto, let's fucking go.
I love
Yeah,
it.
yeah, we'll do another one of these as well once maybe testnet's out, once the ecosystem starts growing as well.
Yeah, that'd be great.
Cool. All right, Keone, thank you so much.